Alright, we're going to begin our study of our final unit called rational functions, also called reciprocal functions. Rational functions, really. But it means our variables are essentially in the denominator more often than they are in the numerator. That's what happens. So the first type of function that we're going to look at is called the reciprocal function. And it's the first type of rational function we're going to talk about. And it's when we have 1 over x as opposed to x over 1, which we typically talk about. So we notice that if we put 0 in here, it's going to cause a problem. Our graph is going to be discontinuous at x equals 0, infinitely discontinuous. So our graph will kind of look like this. So we notice that the graph is definitely going to be discontinuous at x equals 0 because we can't have 0 at the denominator. So this type of graph is called a hyperbola. And so what is our domain? Well, our domain is all x such that x does not equal 0. And our range, well, also y can't equal 0. So we have a horizontal asymptote and a vertical asymptote. So our range, we also cannot have 0 here because we have 1 in the numerator. We can't get 0 altogether for this entire fraction. So our range is also y such that y cannot equal 0. So x and y both cannot equal 0. So our vertical asymptote is x equals 0, and our horizontal asymptote is y equals 0. Alright, now we'll take a look at the standard form of the reciprocal function. Typically, it's going to look like this. Well, you'll have f of x is equal to a over x minus h plus k. So we could have some transformations is what we're saying. So you start off with a parent function of 1 over x, and then you have some transformations that go on where we subtract something from x, we have something in the numerator here, or we add something to the end. So you'll see some analogies to our previous unit. So h is our horizontal shift, so down here h is our horizontal shift. Okay, so we either shifts left or right. So if it's positive, if it's plus, we're going left, and if it's negative, we're going to the right. If it's plus, we're going So if it's plus, we're going left. If it's left minus, we're going to the right. It's whatever number that we need to put in for h to make this 0. That's how we know. So k obviously is the vertical shift. So we're not talking about changing the shape of the graph, just moving it around. So vertical, okay, and we're going up if it's positive, if k is positive, and we're going down if it's negative. And if a is negative, the function is, okay, so if a is negative right here, then the function is reflected, okay? Reflected over the x-axis. So if I put a negative in front here, I'm going to reflect it over the x-axis this way, okay? Over the x-axis. Now, if a is greater than, absolute value of a is greater than or equal to 1, that's going to be a stretch, okay? So that means it's going to get more narrow, okay? So if absolute value of a right here, if that's bigger than 1, then we're going to stretch. And if the absolute value of a right here is less than 1, that's going to be called a compression or a shrink. It's called a shrink or a compression. So our vertical asymptote is going to be x is equal to a number, x equals h. And our horizontal asymptote is going to be y is equal to k, given that we have the standard form of the reciprocal function, of course. So we're going to write a couple of these. So number 1, we have a reciprocal function that's reflected over the x-axis, so we know that a is negative. Then it's translated 4 units to the right, so it's going to be x minus to the right, so it's going to be x plus h, x plus 4. 3 units down, so k is going to be negative 3. So let's put this all together, and then write a function that shows its asymptote. So we're going to have f of x. Well, we know, since it's reflecting over the x-axis, we know that a is negative. It doesn't tell us what a is, so we can just put a 1 for now. Alright, Well, we know we're going 4 to the right, so it's going to be x minus 4. H is, it's going to be minus h here. And since we're going down 3, it's going to be minus 3. This is arbitrary. I can put any number in there that I want, in case you're wondering. Vertical asymptote and horizontal asymptote. Well, vertical asymptote is going to be x equals h, so it's going to be x equals 4. And a horizontal asymptote is going to be y is equal to negative 3. There you go. Now, for this one, reciprocal function, taking that same parent function, we're stretching it by a factor of 2. Stretching means that a is going to equal 2. Well, actually, since it didn't say stretching or actually, I take that back. In this previous problem, it didn't say stretching or compressing, so that's why a is left as 1. So it's not arbitrary. So now we're going to stretch by 2, so that means we're going to have a 2 in the numerator. Okay, stretch by a factor of 2. Translated up 7, so we're going to have a plus 7. Left 1, so that means it's going to be x, x plus 1. So that's how we come up with that asymptote, equation there. So our vertical asymptote is going to be x is equal to negative 1. Okay, and our horizontal asymptote is going to equal to y is equal to 7. And the last one there is a reciprocal function that has a vertical asymptote at x equals negative 2. So it's going to be x plus 2. It has a horizontal asymptote at y equals 5, so it's going to be plus 5. It doesn't say anything about stretching or compressing, so a is going to be 1. And that's it for that one. Any horizontal or vertical asymptotes? Well, it told us that already, so we don't need to do any more. Oops. Sorry if you couldn't see that, I apologize. It told us that the vertical asymptote was at x equals negative 2, so it's going to be x plus 2. They told us that a horizontal asymptote is at y equals 5, so we made that plus 5. There was no mention of compression, so we simply are left with that function. Second page of notes here, we have to graph the equation, identify the domain, range, and the asymptotes. Well, this is a reflexive reciprocal function, and then a minus 2, so it's shifted down 2. So we could take a look at that. So if we graph it, it's going to be shifted just down 2. So instead of y equals 1, it's going to be y equals negative 2. Okay, and this one's going to stay the same. So our vertical asymptote is going to stay the same, but our horizontal asymptote is going to shift down 2, and then it is asymptotic right there. So you can see we're just shifting it down 2. That's all we're doing there. So what's the domain? Well, the domain is all x such that x does not equal 0. Again, x again equals 0. And for range, well, range can be anything except y cannot equal 2. So any y such that y doesn't equal negative 2. The vertical asymptote here is going to be x is equal to 0, and the horizontal asymptote is going to be y equals negative 2. Now for this one over here, we have the reciprocal with a plus 3 at the bottom, so it's going to move to the left 3, it looks like. So instead of being x equals 0, it's going to be x equals negative 3. It's going to be our asymptote. So x equals negative 3. And then we still have the x-axis because it's not shifted down. So the hyperbola, the graph of the reciprocal function is called a hyperbola, if I haven't said that already. It's going to look like that. And so what's the horizontal asymptote? Well, it's still y equals 0. That hasn't changed. It hasn't moved up or down because we have no value of k here is 0. And so what's our domain? Well, x could be anything except negative 3. So it's going to be all x such that x does not equal negative 3. And what's the range? Well, the range could be anything except y equals 0. So y such that y does not equal 0. Alright, so down here for 6, we see that we have a negative a value here, so it's going to be compressed a little bit. Okay. And it's going to flip over, so instead of being in the first and third quadrant, it's going to be flipped to the second and fourth quadrant because we are going over the x-axis because a is negative, so keep that in mind. So, and we're shifted up 1, so that means our asymptote is going to be here. Vertical one is up 1. That's up 1. Yep. So it's going to be a little bit more compressed. It's going to be the second and fourth quadrant because it's reflected over the x-axis. And x equals 0 is still our vertical asymptote. Horizontal asymptote is going to be y equals 1. Our domain, well, x is going to be anything except 0. X such that x does not equal 0. Sorry about that. I restate that. So x, the domain could be x, could be anything except x equals 0 right here. Range is going to be all y except y can equal 1. All y such that y does not equal 1. Okay. Now for 7, we have a couple transformations going on here. So it's going to be down 2. So a horizontal, we start with a parent function at the x-axis. We move it down 2 for a horizontal asymptote moves down 2. And then it's going to be right 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So our asymptotes are shifted there, and it's going to be a stretch of 3, but not reflected, so it's still going to be in the first and third quadrant, so to speak. Well, analogous to, obviously it's not exactly, the quadrants are not exactly the same now. Our asymptotes have been shifted, but that's the general idea of the graph. And then we look at what our vertical asymptote. Well, the vertical asymptote is going to be oh, that should have been x equals 2. 1 second. So it should have been 2. I don't know why I read that as a 5. It should have been 2 here. I apologize. It should have been 2. So just imagine this being put over here. I don't want to recreate the graph, but that should have been a 2, not a 5. That was a mistake. So it should be x is equal to 2 and y is equal to negative 2. Just imagine that was shifted over 2 spots. That's my mistake. I read that as a 5. I don't know where I got that from. I think I was looking at another problem. So the domain here is going to be anything except 2. So x is going to, the domain is going to be x to be anything except 2. And for y is going to be anything except y can equal negative 2. So again, sorry about that. The vertical asymptote, that should have been at 2, not at 5. I read that incorrectly. Okay, moving down to 9. So, oh, not number 9, number 8. Okay, so we have negative 4, so it's 1, 2, 3, 4. Make sure we read that correctly for you. 1, 2, 3, 4. And then down 7. 2, 3, 4, 5, 6, 7. Looks like 2, 3, 4, 5, 6, 7. Okay, and it's not reflected, so it's still first and third. So in this direction, it's going to be a stretch of 2. So we just come down here, and then come in there like that. Come in here like this, approximately. And so x equals negative 4 is our vertical asymptote. Our horizontal asymptote is going to be y equals negative 7. And our domain could be x could be anything except negative 4. And our range y such that y cannot equal negative 7 for obvious reasons. And the last one here, number 9, should be, okay, so we have a is negative, so we're going to switch to these two areas right here. We're going to go down up 5. 1, 2, 3, 4, 5. And then up, so it's up 3 to the right 5, sorry. Up 3 into the right 5. 1, 2, 3, 4, sorry about that. So it's right 5. Follow my own advice. 1, 2, 3, sorry about that. So ignore that. And then what do we have? So we're up over 5 and up 3. So remember, a is negative. So we're going to come here and here. Okay, so our domain is x such that x cannot equal x cannot equal 5. Our range is y such that y cannot equal 3. x equals 5 and y equals 3 are our asymptotes.